Students, whether my voice is audible, ma? Students, whether my voice is audible? I have come in the mobile hotspot.
Yes, ma'am. It's
Now
okay,
my
Yes,
ma'am.
ma'am.
okay. My voice is
Okay, ma'am.
audible. Okay. I think I will share my screen. You kindly tell me whether you can able to. Oh my, no. Can you able to see the screen, ma?
Yes, ma'am. But
Yes,
your
ma'am.
I'm breaking.
voice is
But your
breaking.
voice is breaking, ma'am.
My voice is breaking. Oh my God.
Why? Okay, ma'am. Just
Okay. I will do.
yeah, it's okay right now.
Actually, the problem is net is not connected.
It is okay right now, ma'am.
It's my voice is audible for you, ma.
Right now it was okay, ma'am.
Right now it is okay. Okay, I will sit in this position and I will take the classes. Okay, there is a problem in net. Geeta ma'am, net வந்ததுன்னா சொல்வீங்களா ராதிகா மேம் கிட்ட? மேம் ஹாட்ஸ்பாட்லயே கனெக்ட் பண்ணிருக்காங்க. வரல. எங்க கனெக்ட் ஆகுது? நெட் வருதா? கனெக்டட். ஓகே, இப்பதான் கனெக்ட் ஆயிருக்கு. இப்போ நெட் இல்லைன்னு கனெக்ட் பண்ணேன். கனெக்ட் ஆகல, நெட் கனெக்ட் ஆகலன்னு பண்ணேன். Oh, Ansuri, I think now can you able to see my screen, ma? All these people may make me tensed. I'll starting the strength is 60, come one by one and putting in waiting room. Now can you kindly tell me, ma, whether
Yes, ma'am.
rename dana? Okay, I think I will tell you, ma. You can able to view the screen also. So my thing is, so while we are discussing about race conditions, okay, so in the spooler directory, one by one file will be entered. Okay, so what they have saying now, they are saying in and out to principal. In na, that nothing but printing is over, almost the slots were free. Okay, out means the next file has to be printed. So you just see this spooler directory 1 2 3, 0 1 2, all three or till all this are be printed. Are you clear or not? So now the pipeline, that means the file which has to be printed next will be at the slot of 4 5 6 7. Okay, fourth slot, I have a file name abc and as one program.c, porg.n and all. So this file has to be printed next. But while I'm moving on to my seventh slot, what you have seen that my processors A and processor B both has comes at a time. But processor A has stored in that seventh state, that is next free slot of the spooler directory. But while we are seeing this process B, that comes through the interrupt. Sign பண்ணிட்டு சார் ஃபர்ஸ்ட் அவர் யாரோ வருமா இதுவா சார் இதுவா இது வந்து அந்த அங்க உட்கார்ந்துருக்காங்கல்ல வனிதா மேம், அவங்க கிட்ட கேளுங்க. ஆனா இது இங்க இது என்ன கிளாஸ்? இது எந்த கிளாஸ்? மேம் கிட்ட கேளுங்களேன், நெக்ஸ்ட் மேம் கிட்ட. நான் சைன் பண்ணிட்டேன் சார். So kindly listen, ma'am. So it's a spooler directory 1 2 3 where I have printed my file. That particular slots are free, and these are the next file has to be printed. And the seventh slot, what happened? Processor A has come to the next free slot. At the same time, the interrupt, the processor B has to come. So my CPU has to decide whether processor A has to come or I have to switch to processor B. Are you clear on that? That is race condition. So the two process come at a time, and depending upon how we have to choose us that particular process. Okay, and we will move on to the next slide. How it is choosing. Okay, so the same concept is there. Okay, so here processor A is on the next free slot. So the next free slot means processor A have chosen processor A have chosen the seventh slot. Are you clear? So while you come processor B, so what happened? It will choose the next free slot. Next free slot means automatically the process B will go to which slot? Eighth slot. At the same time, the printer protocol, printer daemon will note anything is wrong on that. It will change all or otherwise process A will be in the seventh slot and process B will be in the eighth slot and it will be printed. Are you clear on that? So two process comes at a time, which has to be considered first, which has to be depending on the protocol and depending on the CPU decision and depending upon the interrupt service routine, it will be decided. I think this is racer. Actually, if they ask race conditions, you may write this example, and this is one of the best example you can write it. How the race conditions were avoided comes and how we can avoid the race condition. That is the next topic. We will see how to avoid the race condition. So two process comes at a time, how to decide the process and how it will be decided. So the spooler directory where all the files will be stored and it will be print one by one. But printer daemon protocol will check always which file has to be print and which process has to be taken, whether this process, whether it is coming in the correct order and all, it will be decided. Okay. The next topic is the next important topic is avoiding racer condition. Okay, that is nothing but the what is the avoiding race condition? We used to say mutual exclusion, mutual principle. We used to say na, that is mutual exclusion. So the mutual exclusion we have to identify and how to do it in a critical time. Actually, this is a process I have explained in the spooler directory. But once again, you assume that my A process is in a critical region. At a time, the big B is coming to enter into the region. We have to denote that it is in a critical region. So at that time, what happened? Process B will be blocked. Till the A is over only, what happened? The B will enter. Are you clear? So to avoid the race condition, two process should not be inside in the critical region. That is very important. So that is mutual exclusion principle. So what we have to do, one processor is in a critical region, we have to put the other processor while entering into the critical region, it should be under the blocked. Okay, so what happened after the process A leave the critical region only, the process B has to come, and once again this B enters into the critical region, we should not allow any other process has to come inside. That is mutual exclusion. That is the thing they have explained. Okay, I think you have understand better what is race condition. So race condition and mutual exclusion. What is mutual exclusion? To avoid the race conditions. Are you clear? So that is betterly explained in the diagram. Okay, the next the topic is ISR. Okay, interrupt service routine and scheduling. Actually, while we are moving on to our syllabus, I think till race condition is over, the next we are going to discuss will be ISR and scheduling. Then we will see priority invention and inter-task communication. Okay, race conditions we over. So almost the three topic is there. So we will see ISR and the thing. Okay, ISR. Oh my God, I went somewhere. Sorry, ma. I went somewhere. Okay. Okay. So almost due to once again, ma. So the time is now 10. Okay. How many of you are willing to take seminar, ma? I will ask, and I think I have received Swati. Swati, how can you send it in my? I almost giving the advice to you to share it in my mail. Is it possible, ma, to share? Where is Swati? Can't you able to hear my voice?
Excuse me, ma'am.
Yeah.
Ma'am, I have also prepared.
Okay, Shashank is prepared. Okay, 10:20 I will give you. I think Swati, it's in my mobile. I can't able to forward it. So Shashank is prepared. Any other students, ma? Any other students? Okay. Okay, student. Okay, you wait. I will complete that interrupt and I will take you to take the class. Yes, Shashank? Okay.
Okay, ma'am.
Okay, so I think interrupt so many times you are studying from 8085 onwards. Interrupt. Okay, I think we can go up to 255 level of interrupts in embedded system. So using microcontroller only, we were all doing. So this is the normal process we have given that. So interrupt we have a highest priority interrupt to lowest priority interrupt. Depending upon the interrupt concept only, it will run. So every time while I'm going to run my ISR. What is ISR? Interrupt service routine. Okay. I will explain you in the next slide how it will be taken. Okay. ISR. You please kindly note down how interrupt is working. I'm taking my class. Okay. What happened? Someone, I have asked anyone, I have stopped my class and I am asking anyone have to take the class. Then Shashank said, yes, ma'am, I'm. So once I asked Shashank to take the class. So he is taking for some 5 minutes. Okay. After Shashank completed his lecture, once again, what happened? I will go back and normally I will take my class. That is ISR. I think you can understand. My program is executing. One interrupt occurs, and what I'm doing, I'm considering okay, it's the highest priority. I have to give the importance. I'm running the particular address, the interrupt service routine. It will go to the particular address and it will run that program. So once that program get overs, once again the processor will come back and the normal program execution will be resumed. This is the way the interrupt will handle, whether it may be 8085 or it may be 8086 or it may be Arduino or it may be a PIC or it may be a ARM7, whatever may be, all the processor will be works in the way. So ISR means interrupt service routine. If one interrupt is coming, where my program has to run, that will be denoted by interrupt service routine, ISR. So what happened? The processor will acknowledge and automatically it will run the particular code, and automatically once the interrupt routine is over, then processor will resume running. Okay, that is ISR. I think you can understand well how the interrupt is occurring. Okay, interrupt latency. I think I didn't move on to the first slide. Why? Because now the interrupt ISR scheduling and all also the preemptive empty scheduling will come. So I will explain one another one. Okay, interrupt latency that I told you, task. Okay, I already told task is a program or a process where happen. Okay, ISR1. Okay, first interrupt comes, it will run interrupt service routine 1, and the second interrupt comes, it will run interrupt service routine 2. When third interrupt comes, interrupt service routine 3. So what happened now, the task is comes, then it will goes to the task. So interrupt latency, where the interrupt latency now in real time kernel, the interrupt, the amount of time interrupts are disabled, whether we have to give to important to the interrupt or we have to give to the priority to the interrupt, all will be given to the interrupt latency. So what is the definition for interrupt? Interrupt we know, interrupt service routine we know, but what is interrupt latency? Interrupt latency means maximum amount of time interrupts are disabled. I can disable my interrupt this much of time plus time to start the execution, the first instruction in the ISR. So how much time the interrupt is enabled and how much time it is executing the first ISR, that is called as a interrupt latency. Are you clear? It is nothing but it is given by the time. Okay, then interrupt response. Okay, in interrupt response, I told you that interrupt response means it is nothing but it between the reception of the interrupt and while the user is using the code, how to handle the interrupt, that is interrupt response. How to handle the interrupt is interrupt response. So that is the response time is given by interrupt latency plus time to the same CPU context. That is how much time it is come back to the original time. Okay, there we have a two kind of scheduling we have seen: non-preemptive and preemptive kernel. So non-preemptive kernel and a preemptive kernel. I think while giving definition, I can directly move on to the diagram, and then you can understand well. Okay, you kindly see this, ma. Preemptive and non-preemptive kernel. I think please kindly note down preemptive and non-preemptive kernel. Okay, so that's why we have seen ISR and scheduling. So for what preemptive, you just see low priority task. Okay, it is running its ISR, interrupt service routine. Once one high priority task comes, what I will do, that a preemptive kernel that will give to the priority to the higher priority task, then it will run the high priority task. Once high priority task is comes, then only finish it that particular task, then it will come back to the low priority task. How the way preemptive kernel, I think yesterday I have given that one example with the processor time, how it will handle. The same thing is that preemptive means it will give depending on the time. Yesterday we have seen that first it will take the zeroth time, then it will take the next time, one, two, three. I think I will go after this slide. Okay, so preemptive kernel means first it will run the lower priority task, then what it will do, it will run the corresponding ISR. Then once what happened, it will make next high priority task comes, it will go and run that high priority task, then it will return back. That is called as a preemptive kernels. Okay, non-preemptive kernel. What is non-preemptive kernel? Okay, I think you have seen that one low priority task is running. Okay, so what happened, I'm receiving my high priority task, but what it will do, it won't respond anything. It will come back and it will run the lower priority task. Then after completing that only, it will go and run the high priority task. It's nothing but you have seen ISR can make a higher task to ready to run, but IS always return to the interrupt task, then only it will run to the high priority task. So after completing the low priority task, it will come back and then only it will run the high priority task. So it is nothing but it is what it will do, it will do the current task and it will complete that, then only it will go to the high. That is non-preemptive kernel. I think yesterday I have gone with one simple example for this case. Okay. Uh, Preemptive schedule and a non-preemptive. So we have seen here non-preemptive. So first what it will take, P2. Have you seen this? Yesterday I have taught you. First it will complete P2. Then it will complete P3, and then it will complete P1, then it will complete P0, because here the arrival time is 0, 1, 2, 3. So it will complete as it is. But preemptive schedule, it's not that. So one it will do P2, then it will goes to P3. And what happened now? It will check the CPU burst time and it will check the algorithm. Any other important that it will pay the attention to that and it will run that. So preemptive schedule means it will always gives the priority task, it will run the task, then only it will come to the low priority task. But non-preemptive, it won't give any priority to the task. It will complete the entire cycle. It's like a round cyclic algorithm. Okay, so once it completes, then only it will return back to the high priority task. So that is preemptive kernel and non-preemptive kernel. Okay, so interrupt recovery. Okay, I told you number of time the processor return to the interrupt code, that is interrupt recovery. Okay, so whenever I am calling, it will go back and it will turn. So I think the next diagram, you just see preemptive and a non-preemptive kernel very well. So we have seen three times: interrupt latency time, interrupt response time, and then one more interrupts recovery time. Three times we have seen. Okay, interrupt latency means maximum we have disabled our interrupt response. Now it's nothing but the reception of the interrupt and how the user will handle the interrupt, how we are responding to other. Once I ask the question, some students will immediately respond to me. Some students after taking my class at the end and for the attendance only they will ask. So the response will be depending upon the scheduling algorithm. And the next one is interrupt recovery. So how much time it run the interrupt code, that is interrupt recovery. So we have three time: interrupt latency, interrupt recovery, interrupt response. How to handle the interrupt will be interrupt response. How the user code is authenticated to the interrupt, that is interrupt response. Interrupt recovery, now how many time the processor is running the interrupt code, that is interrupt recovery. Interrupt latency means maximum number of times the interrupts are disabled. Okay, now you go for preemptive and non-preemptive code. I told you non-preemptive means what? Once it complete all only it will come. Interrupt latency. I'm giving I'm doing one task. Okay, so I'm doing one task. One interrupt comes inside. Kindly give the attention to that. So what I will do? I'm giving some time for my interrupt is disabled during this period. So what I'm doing? I'm not checking that interrupt. So once it is my interrupt latency time is over, then I have to, my CPU has to come and automatically I have to respond to the particular interrupt. After responding to the interrupt means what? I have to run that ISR code. So once my ISR code is run, I have to have my recovery time. I told you interrupt recovery. It is nothing but how many time I'm handling my interrupt code. So once it done the interrupt recovery, then automatically the CPU will come back to the position and we have to handle the task. Are you clear? So interrupt latency means what? The interrupts are disabled during the prayer, so I won't give priority to the interrupt. So I'm not giving any priority to the interrupt. I'm not going to handle any interrupt. So at that time I'm performing my task alone. Are you clear? So after that there's interrupt response. Okay, my CPU has to handle the interrupt. So interrupt response time comes. So once it comes, what happened? My I have to run my ISR, interrupt service routine. So once my ISR is over, interrupt recovery. So interrupt recovery means I've told you I have to recover the how to I have to repeatedly then the processor to return to the return to the interrupted code. Okay, so time required for the processor to return to the interrupt code. Then similarly it will go to the particular task. Now you go this is non-preemptive. Preemptive, I told you preemptive. Interrupt is comes. Interrupt latency, my interrupt is disabled during this period. Then interrupt response. Okay, my CPU will comes into the picture. So I have to run my ISR, interrupt service routine. So once in the interrupt service routine, what happened? One more interrupt test comes. Are you clear? Here they have given A, B is there, which is highest priority. I have to check it and I have to run that particular, and then only I will go back to my task. And similarly here, but here it's not like that. We all know it will complete his task and then only it will come back to that. But it is not like that. It will give some attention to the priority task and it will run that priority, whether it is a task A or task B. It will check the priority here and then it will respond to that. Can you understand or not? So that's why this is called as a preemptive and this is called as a non-preemptive kernel. How it is running this ISR, interrupt service routine. Okay. Then the next topic is semaphore. Okay, semaphore is, I think, it's nothing but how I am saying. You know the question true or false,
Ma'am.
or it may be in the form of binary, 0 or 1, whatever may be. So depending upon that, mainly what the semaphore is used now to control to share the resource. That is avoiding mutual exclusion means what is mutual avoiding race condition. So how to avoid the race condition, how to signal the occurrence of events, and how allow to two tasks synchronize their activities, that is called a semaphore. So it is nothing but whether we have to do or not. Okay, true or false, 0 or 1, all will be taken for semaphore. It is a type of protocol. It's nothing but it is a type of protocol mainly for a multitasking kernel. The semaphores are used. You always remember how we have seen some microcontroller is dedicated to this application, and sometime we will think this protocol is doing the purpose. Similarly, RTO, real-time operating system, is doing that much. Not definitely, some protocol has to be helpful for for that. So kernel is the one of the nervous of the operating system. So that will only decides the which interrupt has to be run and all. And the decision making, that is also done by one more protocol, semaphore. And it is mainly for avoiding the race conditions. And it will find out how many events are there, and if two tasks are there, how to synchronize the task and all, decide by the semaphore. Okay, I think you see the example for semaphore. um, Task 1 is coming, task 2, I told you process A is coming, process B is coming. I am task 1, I am task 2. So what the semaphore will do now, it will see that which has to print first, that will be decided. And the particular task will be printed first, then the next task will be printed next. So semaphore, we were saying, it's a key, or it is avoiding the mutual exclusion. And similarly, it will count the number of signal occurrence, and how to synchronize the two tasks, that are all done by with the help of semaphore. Okay, so I think you will see one best example they have given. While you enter into the restaurant, and you are seeing how many vacant table is there, and how they were occupying the table, the same concept. When you see, you are seeing that when you enter into that restaurant, what happened, even it is a morning time, no table will be occupied, because no, you are the first one. So once you occupy the table, what they first do, they will keep the water in your table. That means you have occupied the table, you have been sitting at the table. That means the remaining tables only free. So what happen, if each person come one by one, what the first way they will do, they're never going to serve the food, they will take the time, and they will serve the food, that and all. So first what they will do, they are allocate, they will give you the water for you. That means the number of table they kept the water, means the number of tables are occupied, only the remaining tables are there. So once you say that all the tables are occupied now, if the new arrival or new person is entering into the hotel, they has to be seated outside. That means they are in the waiting mode, they can't able to come. Once you have completed your course, you are leaving the particular hotel, then automatically the waiting person will come inside and sit in the side door. Now what happened now, the new person is entering into the table, and they were sitting, and once again we will keep the water for them. So this is the way they are saying how to occupy, and how the students were occupying the table. And similarly, you have to understand that it is the waiting principle is also there. So this is nothing but I have explained about the semaphore analogy. So you have to, today we have seen two questions. One is race conditions, I have explained with you one process. And the next one is how to avoid the race conditions. Okay, we have used the mutual exclusion principle, and then interrupt, and how ISR is running, and what are the time period, three time period you have to take: interrupt latency, interrupt response, and one interrupt recovery. Okay, so the three time you have to be understand well. So interrupt latency means you have to know how much time the interrupt is disabled. Interrupt response means how the user will handle the interrupt. And the third one is interrupt recovery, how the processor to return to the interrupt code. That is interrupt recovery, I have to recover na, that is okay. So we have explained in actually this is interrupt as a foreground and background they have explained. It is similar to non preemptive schedule only, but we have explained for preemptive kernel how it is handling the ISR, and non preemptive how it is handling ISR we have seen. So task interrupt latency, where the interrupts are disabled, so we were not pay the attention to the interrupt. So once our CPU contest time comes, now ISR will comes, we will run the particular ISR code. Even it is a kernel, it will check for the highest priority, and it will whether it has to run the task A or task B. But non-preemptive algorithm, no, it will run back the original low priority task, then only it will go and check the other priority task. Okay, that's then why I have explained the semaphore now. In priority invention and inter-task communication, only these two topics are left out. Okay, priority invention Okay, priority invention and intertask communication, they will use the semaphore protocol. So the semaphore is a protocol mainly to avoid the race condition, and it will count the number of signals at a event, and similarly it will synchronize and do the activity. So simply remember the restaurant and the table, and how the persons were waiting, and how we were allocating by keeping the water in each table. And if we want to four table is there, and two persons from different family came, if they accept, what we will do, we will keep it in the same table. The semaphore will do all these things. So the priority invention and intertask communication, uh, we will see in the next class. Okay, ma. Okay, Shashank. Shashank.